One last topic to discuss with regards to classes and objects is the topic of objects and functions. How do we pass an object to a function, or can we even do that? Yes, we can, and it works like any other variable. So once you define a class, you're going to have a new type to declare variables with. And once you declared a new class variable, i.e. an object, you could simply pass it to other functions. So in this case, my ball is our class variable or object. Object basically equals class variable. We can pass that variable to a function like any other variable, and there is no extra syntax required. So function foo is receiving a parameter of type ball, and the name of the parameter is b. Objects, just like arrays, are passed by reference only, which means you could change b here and it's going to affect my ball. So basically b is a reference to my ball underscore. So if you change b, my ball is changed back in setup. So this is just like arrays, and it works unless you break the reference link, and you could break the reference link by assigning b to something else. So for example, if in function foo, if I said something like b is equal to new ball, that means I've created a new object for b and assigned b to that new object. Therefore, the link is broken. This would cause the link to break. So let's go through this function step by step and actually draw the memory diagram and see how it works. So if we have class ball, and let's just say it has an int x and y, and if we have void setup, in setup we have actually let me just come down here. So we have void setup, and in here we have ball so we create a new object. And if I have a function foo, I can just pass my ball to function foo if function foo is defined as such. So I'm just sort of rewriting the slide just to make sure that we are following. So the type of the function is, of course, the type of the parameter we're passing is ball. The name of the variable I'm passing is, I can choose any name for it, so I'm just going to call it b. And in here, I can say b.x is 10 and b.y is 20. Let's draw the memory diagram for this. So we have setup. Don't forget, for our class definition, this is the class definition, nothing is loaded onto memory. So we say ball, my ball is created in setup, and this is setup. So we have my ball. So when my ball is created, all the variables in my ball are x and y, and they're both set to 0. They're both initialized to 0. Then we call function foo. When we call function foo, foo is created in memory, and foo has no local variables, but it has arguments that are going to be here. It's going to have arguments. Argument is a variable of type ball. So b is going to be here, and b, just like the case with the arrays, has a link to my ball. So b is a reference to my ball. Basically, the address of my ball in memory is stored within b. That's what the link is. So the link is an address. So so b is actually storing the address of my ball. That's what's happening. So there is a link. That's basically a link. So now here, if we are in foo, and I say b dot x, so the address goes b dot x, it would be looking at my ball, that would be changed to 10. And then b dot y equal 20, this would be looking at b, then going to y, and it's going to change y to 20. So you see, there is a link, so it works exactly like it was before. Then for the arrays, then this function is done. When this function is done, that means foo gets destroyed. The link between b and my b1 doesn't exist anymore because b doesn't exist anymore. And this is what you end up with. You end up with setup, and the values are changed as such. Alright, let's do another example with pass by reference with objects. So we have the object my ball that has been declared and constructed in setup, my underscore ball, and it's going to have variables x and y included within. And then we're going to call function foo. When we call function foo, it's empty right now. I don't have any code within it. But still, what happens is, so no local variables right now. B is passed. So B is a reference to my ball. So B is a reference to the my ball object. Okay, so B is a reference to the my ball object. And as long as I don't break that reference, everything is going to work fine. So for instance, if I go ahead and say b dot x is equal to 7, then x is going to be 7 in memory. However, if I go ahead and say something like b equal new ball, here I am breaking the link, the reference link. Why is that? Because then I'm assigning b to a new object. So b is going to be its own object now. It's not going to reference to anything. And it's going to have x, which is 0, y, which is 0. So now, if I go ahead and say b dot y is 60, guess what? I'm going to have 60 in here. So y is actually going to have the value 60 here, but there is no link. By the end of this function, and this was function foo, of course. By the end of this function, when we reach to end of function foo, it is destroyed. It's not in memory anymore, and x is set to 7 because that's when we had the link. But as soon as we broke the link, then we changed y, but it wasn't changed back in setup. So that's very important to be aware of. All right, let's look at another example of pass by reference. This time we're going to be looking at a swap function. A swap function is a function that, as I have here, basically takes two variables and swaps their content. In this case, it happens to be two objects. So we have first ball, we have second ball. We are initializing, or actually we are assigning values to the member variables. So we have something like this. This is set up just prior to calling swap. We have first ball, which has x and y. They're initially set to 0, but then we put 10 and 20. And then we have, of course, second ball. They're again 0 to begin with, but we put 5 and 2 inside. And now the goal is we want the member variables of second ball to be copied in first ball and first ball to be copied in second ball. So at the end, when we have the output, we want this to output, for first ball, we want it to output 5 and 2, and second ball, we want it to output 10 and 20. First of all, the swap algorithm is so that if you had two integers, let's say, and so I draw a memory diagram for everything. You guys should be really good at memory diagrams right now. So x is 10 and y is 20. If I wanted to swap their content, of course, I would need a third variable. It's just like if you had a glass of milk and a glass of juice. If you wanted to swap the content, you would need an extra container at least to pour the juice into that extra container, and then pour the milk in the empty glass. Well, I guess you would wash the glass first, but that's besides the point. So we need a variable temp let's say temp is garbage to begin with, or so you would basically say you would put the content of x into temp. So temp is going to be 10 now, and then you have the content of x saved. The content of x is not going to be erased, so you can set y to x. So you copy y to x, so x is going to become 20. And then at the end, you can say, you can copy the content of x, which is saved in temp, temporarily, into y, so y will become 10. That's the algorithm. So what you should do is you should pause the video and try to write the definition for the swap function for yourself, and hopefully you get it working. So you copy this code and write the definition for swap, and then start the video again and see if you have the same answer as I do. Alright, so hopefully you tried this on your own for a bit at least. Now let's look at the solution. Before we get to the solution, I wanted to show you an incorrect solution first. So here we make an object called temp, and then we are setting temp to A. And I said that this is not, we are not going to do this in this course because this is going to make temp a reference of A. So and it also breaks the links. So if we basically don't do anything that copies an object into another object. All right, let's now look at the correct answer. The correct answer is, of course, we're going to have an integer temp. First, we're going to assign the value of x, swap the values of x and y in objects A and B. So notice that temp is not an object here, it's an int. And then we're going to use temp in swapping the values of y in A and in B. So to quickly show what it's like in the memory diagram, so we have setup. It's a different color. I'm going to draw a swap. In the argument section, we have A and B. If we go back to our code, to our setup function, we see that A and B, so first ball is sent first, then second ball is sent. And in our swap function, you see that A is first and then there is B. So A is a reference to first ball and B is a reference to second ball. Then we have temp. The value of temp is, of course, 0 to begin with. Then we go here and we say temp. We set temp to A.x. A.x is, so A is linked to first ball. A.x is 10. So the value of temp becomes 10. Then we say A.x is to be set to B.x. So B.x, B is linked to second ball, and B.x is 5. So 5 is going to be copied into A.x, which is 10. So this is going to become 5. And then B.x is set to temp. So B.x was 5, is going to be set to temp. That's 10. So we are in the scope of swap, but B is linked to second ball. So second ball and is being updated real time. Then we go to the second portion when we want to swap the y values. So temp is set to A.y. A.y is the y in first ball. So temp is now set to 20. Then A.y is set to B.y, so this is 2. Then B.y is set to temp, so this is set to 20. We are at the end of our function, so what happens is swap gets destroyed, it's no longer in memory, and the links are of course gone, and we have two objects that have been swapped. All right, thank you.